Assalamu alaikum. My name is Saba Maqsood and I am currently doing mechatronics engineering from a University Islamabad, and I am going to show you my lab 2 tasks. As you can see, we were given these tasks, and first task is that we have to store R16 30 in register 16, and then we have to display it, and then we have to add 25 in that value and show result on any port, and then we have to clear R16, and we have to do this work in Acme Studio. As you can see here, this is my lab task 1, which I have done. And as you can see that I have stored 0 cross 5 ff in R16, and then I have given the output, and then I have stored 30 as binary in R register 16, and then I have shown output on port B, and then I have added 25 in R in 30, and then I have shown the output again on port B, and then I have given then I have cleared the register 16 as mentioned in the question. And as you can see, I have used a simulator, and when I simulate my task, you can see that it's been simulated, and then this is my output of question number 1. And I can show you my input output variable as 1, as I have given port B, and if I give it any input, as you can see, then it will, as you can see, it will appear in my as 0 cross 1e. And if I show you my registers, so it's currently not showing registers, so it is highlighted also there. Now I will show you my lab task 2, which is this, in which I have to do take an input from one port and display it on another port, and then we have to simulate it, and then we have to run it on Proteus 2. So as you can see that this is my code 2. So as you can see that I have assigned it 2 outputs, and then I have displayed, and I have given it any input, and then I have displayed it on port C. I have given input at pin C, and then I have displayed it on port B. So this is my code. And now on Proteus I will run it too. Again I have used simulator, and then when I debug it, so this is my output. This is my output, as you can see. Now I'm going to show you my Proteus, which is this. Now coming towards activity 3, I have to show you display charging sequence of LEDs on any port, simulate on Acme Studio as well as Proteus. So I will show you my task 3. As you can see here that this is my last tree, in which I have shown LEDs. First it will turn on LED 7, and then LED 6, then LED 5, and like this it will go to 0. So I will run my code 2. As you can see, I have again chosen this simulator, and when I debug my code, it will be like this. Now it's been successfully compiled, and this is my output of activity 3. Now I am going to show you it in Proteus. As you can see, as I have to open project, As you can see, this is my code for Proteus. I have called a delay, and I have assigned a delay of 90 and 30 for D0 and D1, and this is my whole code. And as you can see, my code is successfully running. As you can see, first D7, then D6, D5, D4, D3, D2. As you can see, the LED is charging one by one from D7 to D0 successfully by a delay of 90 microsecond. On Atmega. Okay, so now I will show you my fourth code, sorry, which is we have to take two values from different ports and compare them. If those values are same, then this will come in output, and if they are not same, this number will come in output, and I have to simulate it on Atmel Studio and Proteus as well. So as you can see, I will run my code 4. As you can see, this is my code 4. Now I have assigned it I have assigned two output ports, D and B, and then as you can see, I have given input at pin B and pin D, and I have compared these two registers, and if values are same, it will print this, and if not, it will display this binary number in register 21. This is my whole code, as you can see, and I have displayed the output on port D. So now I will run my simulation. I have again selected simulator as a debugger, and now I will debug my code, and it's been successfully compiled, and as you can see that this is my output. It's been successfully compiled. So now I will show you my Proteus work. As you can see, so as you can see, this is my Proteus work. I have done this on Atmega 328, and this is my source code. As you can see that I have written same source code as as I have written it on Atmel, and now when I run this, it will be successfully compiled, and then you can see that the two LEDs glow. That means that the inputs are same, and if I change the input combination, as I have now given this input, and when I change my this then a binary number, then it will glow two different LEDs. Now coming to my code 5, in which I have to implement these codes and write about their functions. So now I will show you these codes. I have done it on Word. As you can see, first I have written STS code. In STS code, we have to store any register into a data space location. It is opposite to LDS. And now as you can see, I have given an example in which I am storing R16 into 0 cross 390 hex location, data space location. It's basically an address. Now it stands for output. So as you can see, I have given it the code. Basically it gives output R22 SPL. It stores GPR to any input or an output register. As you can see, it's totally opposite of input. And you can see now coming to this, I have moved. This is basically moved. I have moved R24 data into R21 data. I have moved first register's data to second register. In JMP command, what we have to do is that it means that this the data will be saved there forever. As you can see, I have